Welcome back, and today we're going to be talking about 8.4 Day 2. Today, what we're looking for is what's a method of an algebraic skill of what's called factoring. Factoring, if you think back to what we did yesterday, it's actually going to be trying to reverse the order of our operations from before. We're trying to undo distribution is the goal today. So when we look at this, we're going to start off with what's called finding common monomial factors. Okay? So one way to write a polynomial in factored form is to find a common monomial factor for each of the terms and apply the distributive property. So here's an example in which we are going to be looking at 18x squared minus 24x. We can actually write this in several different forms, several different factored forms. So we're going to start with filling in these blanks to complete each factorization. So if I look at 18x squared minus 24x, now try to think of this backwards. If this was a 2 in front, I would have to distribute it to something here to the two terms to result in 18x squared. So if I think backwards, 2 times something gives me 18x squared. So hopefully you recognize that's going to be a 9x squared. Same thing with the 24x. 2 times something needs to be 24x. So if I think about it backwards, I can actually kind of just divide by 2. 24 divided by 2 is going to be 12. So I get 12x here. So that's the first option. In part B right here, what happens if we decide with an x? So if I have an x, again, this is trying to say x times something gives me 18x squared. That's the first step. So x times 18x is going to give me 18x squared. Same thing with a 24x. X times 24 will give me 24x. Option C here is doing both 3 and an x. So again, I'm trying to say 3x times blank gives me 18x squared. So if I think of it backwards, 18 divided by 3 is 6. X squared divided by x is x. And then the same thing for the second term. 24 divided by 3 is 8. X divided by x is just 1. So I have 6x minus 8 left over. So for part D, 18x squared minus 24x, we're going to take out a 6x. So let's see what happens when we take 6x out of everything. And again, we're saying 6x times something gives me 6x squared. So that should be a 3x here, and it should be a 4 here. So here's the thing we want to look at here. These are all valid factored forms, but we look at our common factors. 1, 2, 3, 6x, 2x, and 3x, and 6x. So which of these do you think would be the greatest common factor? Hopefully, you would say 6x. For me, my explanation would be that 6 is the largest number that we can take out, and x is the largest variable we could take out in terms of the powers. So if my goal is to complete my factorization, in each of these cases, option D is the complete factorization because we took out the greatest common factor, or GCF here. So let's do a couple more examples of those. So we have here 40x minus 5. Well, I don't have x's in both terms. All I'm going to focus on is the 40 and 5. What number can I take out of both? So that's going to be a 5. If I take a 5 out of 40x, that means I'm reversing the distributive property. So think of that way, I'm going to divide out the 5. So I have 8x left over. Some people think that you take a 5 out, so out of the second term it's done. But remember, it has to be able to distribute to get back to that original setup. So if I take that out, it's actually going to be a 1 left over, and it's going to be a minus 1 here. For part B, this one has multiple terms, I have a coefficient and a variable to work with. So I'm going to start with the 36 and the 27. What number can I take out of both 36 and 27? I'm going to tell you right now, you may do this in multiple steps. You may take something out and realize, oh, I could have done one more thing. Just go ahead and do that as a second step. I might as well do that in this case here. Because 36 and 27, I'm going to recognize that I can take a 3 out of everything. Okay? X squared and x, they both have a single x in them. So I'm going to take out an x out of both of those. So 36x squared, if I take out a 3x, is going to be left with 12 x. 27x taken out of 3x is going to be left with 9. Well, when I look at my resulting binomial here, I'm going to notice I can actually take more out of that. 12x and 9 can both take a 3 out of that one. So when I took a 3x out, that was not my greatest common factor. It's still a factored form, but it's not my greatest. So I'm going to take out an additional 3. So if I do that, I'm going to take out a 6x in the end. Okay? Then I'm going to be left with, whoops, sorry about that. If I take a 3 out, that will be left with a, hold on, sorry. Let's erase that. Minor mistake. Here's the thing. If I'm taking another 3 out of this part, what I'm going to have is 3 times 3x is going to give me 9x. And then I'm going to be left with 4x squared. And I take a 3 out of the 9, that's going to give me a plus 3 there. This is my final complete factorization right here. Part C. I'm going to look at my variables real quick, and I notice I don't have x terms in everything. So I'm only going to be able to take out a number here. So I've got 14, 7, and negative 21. I can take a 7 out of everything. I'm going to be left with 2x cubed plus x squared minus 3. And for my last option here, I do have x and x squared, so I know I'm going to be able to take out an x. 15 and negative 25, that should have 5 as a common factor. So I do that, I get 3x. Whoops, sorry. I'm done with x, so I took out I'll have 3 left over minus 5x. And again, in each one of these cases, go ahead and multiply it back out just to make sure you have the right form. If I take 5x times 3, that's 15x. 5x times a negative 5x is a negative 25x squared. So I know I'm good. So again, what the message today is I want you to think about reversing distribution. How should it look if I were to take out stuff in terms of distribution? Because that's what's going to lead us to this, factoring trinomials. Each of the trinomials, we're going to be trying to factor these. So if you remember from yesterday, when we did our multiplication, right here, x squared plus 9x plus 20, that is the result of something like this. We're going to have two binomials that come together to make this trinomial. So let's think about this in terms of, let's logically work it through. I know for a fact that for me to get an x squared term in the front, I need to have an x and an x. Okay? I know that I have a positive 20 at the end here. Okay? So because of the positive 20 and it's a positive sign in the middle, that is a result of multiplying two positive numbers together. Because if it was a positive and a negative, then my final term here would be a negative. If it was two positives at the end, or a positive at the end, and a negative in the middle, it was a negative 9x, then I know that I have to have two negatives in here. You'll see some more examples of this when we get to it. But for now, I want to focus on this. I need two numbers here. Those two numbers need to multiply to 20. Well, if I think about this, I've got what multiplies to 20. I can do 1 times 20. I can do 2 times 10. I can do 4 times 5. Those are my three options here. But here's the thing. If all three of these are multiples of 20, or factors of 20, I could put any of them in there. The problem is, what is going to result in a 9x in the middle? So logically speaking, I can try checking everything. Let's just try it out real quick because there's not that many options. So if I do this here versus x plus 2 times x plus 10, and then my last option is x plus 4 times x plus 5. Run out of space here, but it's okay. Okay, I'm going to go ahead and distribute these back out, see which one gets me back to the original problem. So x squared plus 20x plus 1x plus 20. Combine these two together, I get x squared plus 21x plus 20. So that one's no good. That one does not actually work, does not get me back to the original. Here I've got x squared plus 10x plus 2x plus 20. Put these two terms in the middle together, we get x squared plus 12x plus 20. Again, 12x does not match up to 9x, so get rid of that. Here I've got x squared plus 4x plus 5x plus 20. Whoops, okay. Put those together and I get 9x plus 20. There it is. That one works. Therefore, x plus 4 times x plus 5 is my same equivalent factored form here. So I did this is calling it a guess and check. If I looked at knowing logically that I have to multiply to 20, I looked at all three possibilities. Hopefully you're seeing that there is a pattern here. The 4 and the 5, sorry about that. The 4 and the 5 not only multiply to 20, but they add up to the 9. So we want to add here and multiply here. This pattern applies to pretty much everything we're going to work with our factoring, and is very helpful for these next steps. Okay, so for the number 4 here, again, I'm going to look through this. I know it needs to be x and x. I got a positive at the back end, but the middle term is negative. The only way for that to work out is if I have two negative numbers inside here. So now the goal is what multiplies to 15 adds to a negative 8. Negative 3 and negative 5. So again, if I want to check it out, multiply it back out and make sure it does work out. Option 5. This one's a little different. Okay? So for my answer here, you notice that this is a 2x squared. Here's what I know logically. I know it needs to be a 2x and an x. That's the only way for this to be able to distribute back out to what it is. Okay? I know it's a plus here and a plus here, so I know it's got to be plus plus. Okay? Now as for the numbers, again, these numbers are going to be multiplied up to 6. Here's where the guessing and checking has some more guessing involved. What I need, if I need to multiply to 6, I know that is 1 times 6 and 2 times 3. So from this pattern, I actually have 4 possibilities of what's going to work here. Okay, I could possibly have 2x plus 1 times x plus 6. I could have 2x plus 6, x plus 1. 2x plus 2, x plus 3. 2x plus 3, x plus 2. These are the 4 possibilities. So I'm going to go ahead and multiply these real quick just to make sure what's going to give me 13x in the middle. So here I have 2x squared plus 12x plus 1x plus 6. Well, there it is, 12x and 1. I'm actually done because that worked out. So I've got 2x plus 1, x plus 6. Just to show you what would have happened with the other ones, just try it out real quick. So I have 2x squared plus 2x plus 6x plus 6. These add up to 8x, so we know that's not it. Okay? 2x squared plus 6x plus 2x plus 6. So 6x and 2x is 8x, so that one's no good. And then 2x squared plus 4x plus 3x plus 6. And again, 4x and 3x come together. It is not 13x, so this one's no good. So this is the only good option here. This is our guess and check method here. So let me do a few more examples, and we'll just go off of the guessing and checking just to make it a little bit quicker for today. Tomorrow, for the next lesson, we'll go over one more type of method that makes it a little less guessing and more of a pattern to go through. So here I've got, for my answer, I know it has to be 3x and x. Because it's a negative here and a positive here, I know it has to be 2 negative signs. So when I go through here, I know it's got to multiply to a positive, it's got to multiply to a positive 10. So my options there are 2 and 5 and 1 and 10. So when I do this, I'm going to find out that it's going to be 3x minus 2 and x minus 5. Okay? X squared minus x minus 56. This one's going to be a little bit different than what we've done. Again, I know my pattern needs to be x and x here. I have a negative number at the end now. So there's actually only one possible way for that to occur, and that is if my two terms are positive and negative. I have a negative 1 in the middle. So I know that if it's a negative 1 in the middle, this number is bigger. So I'm trying to figure out what multiplies to a negative 56 but adds to a negative 1. So, hopefully you figure that out. Give you a pause real quick. It'll be a negative 8 and a positive 7. And again, you can check it out for yourselves and try it out on your own. Last two examples, we have x squared minus 25 here. So this one's a little bit different because we don't have a middle term. But we can treat it like this. X squared plus 0x minus 25. If I think of it this way, I'm going to go off of here. I know it needs to be x and x. I know it's a negative here, so I know it's got to be a plus and a minus. Well, since my middle term here is a 0x, that means if I were to multiply this back out, the two numbers would have to cancel each other out. Well, the two numbers also have to multiply to negative 25. So what multiplies to a negative 25 and adds to 0? 5 and 5. Or 5 and negative 5, I should say. Okay, the last option is our last example. X squared plus 5x plus 8. So x squared, I know it's going to be x and x. It's two positive numbers, so I know it's positive and positive. So now it needs to be what? Multiplies to 8, but adds to 5. Uh-oh, I've got some trouble here. If I try to multiply to 8, here are all my possibilities of multiplying to 8. I've got 4 and 2, 1 and 8, and that's it. If I add these together, the addition of these, I get 6 and 9 here. Doesn't work. Therefore, I actually cannot factor this. This is not factorable. So if I cannot factor it, I'm done. If I directions say to factor the trinomial and I can't factor it, then I'm done. Nothing to do. Okay? So we looked at two types of factoring today. We looked at how to factor with pulling out a greatest common factor, usually a monomial term. We also talked about how to factor trinomials by thinking of them as undoing distribution. So we turn trinomials into two sets of binomials. That concludes our 8.4 day 2. Tomorrow we were going to look at one more method of doing our factoring that is, like I said, a little bit more pattern-based versus just guessing and checking.